Today's probability, we're dealing with probability of two events, so not just one event. These events can be one of two things. They can be what's called disjoint events. Disjoint, sometimes we also refer to as mutually exclusive. Disjoint or mutually exclusive. Disjoint or aka mutually exclusive events are events that have no outcomes in common. Whereas the opposite of that, overlapping events can have one or more outcomes in common. One or more. Okay. And what I mean by outcomes in common is, okay, so looking at this table, disjoint, aka the mutually exclusive one. So if you're trying to find the probability of these two things, the first probability is getting an an odd number. So you can see that over here. These are the odd numbers. Your second probability would be rolling a 6. I guess we're talking about a die. A die. Okay, do good. Okay, you can see 6 over here. So these don't overlap. There are no 6s that are also odd numbers. These are called mutually exclusive, not overlapping, disjoint. You can see the two that are just not in anything would be the numbers 4 and 2. 4 and 2 are not odd and not a 6. And then you can see how overlapping events, they do have an event that, or an outcome that would be in common. Your first probability, you'd be asked to get a number over 4. So you can see that here. These two numbers are over 4, 5 and 6. And then getting an odd number is the other event. So you can see odd number is over here. Odd numbers on a die are 1, 3, and 5. And you can see they do have an outcome in common. This 5 is both a number that's over 4 and it's odd. So when you calculate the probability, you'll have to account for the fact that this one shows up in both. And you'll have to actually subtract off the fact that it shows up in both. We're wide awake today, honey?
I'm wide awake.
Okay, thank God. All right, I'd let you have a sip of my coffee otherwise. Okay, let's just first figure out if we can tell whether these are disjoint, aka mutually exclusive, or overlapping. So for the first one, we're talking about rolling a dice. Sorry, Danny. And the first event is rolling a number less than 4. The second event is rolling a 5.
Wait, when it says less than 4, is it 4 and less? Or just like less?
Less than 4, so just 1, 2, 3. Yeah. Do those have any events in common? No, so that is disjoint, or you could call it mutually exclusive. Those are synonyms. Okay, the second one, we're talking about randomly selecting a student at school. The first probability would be probability of selecting a sophomore. Probability of selecting a boy. Those overlap at all? Yes, there are sophomores that are also boys, so these would be overlapping. So when you're calculating that probability, you'll have to subtract the overlap amount. Okay. Last one, we're choosing a book to read. Okay. First probability is choosing a hardcover book. Second probability is choosing a fiction book. Do those overlap at all? Yeah, there are hardcover books that are also fiction books. So those would be overlapping. So we would have to subtract the overlap probability amount. Okay, doing okay so far? Okay, disjoint events. So we're going to start with just calculating some disjoint events. Okay, again, disjoint, these have no events in common, no overlap, mutually exclusive. They cannot occur in the same trial of an experiment. So the probability that either event occurs is the sum of their individual probabilities. And you'll often see the word or on these probabilities, probability of A or B happening. Probability of A or B happening would be the probability of A plus the probability of B. Probability of A plus the probability of B. Alright, I went ahead and got out my card deck breakdown handy because these questions do have to talk about cards. So let's look at our first one here. Again, these should all be disjoint. They should not have any overlap. Okay, so the first one says drawing an ace or a face card. So let's just start with probability of drawing an ace. Probability of ace Or means we're going to have to add them. Probability of face. Okay, starting with just probability of getting an ace. How many aces are there? There's 4 aces. Out of how many total cards? 52. And I usually won't simplify until the very end, because sometimes if you simplify first, then it's more annoying to add them. And then or tells me I'm going to need to add face cards. How many face cards are there? There's 3 for each suit. So how many total? 12. Yeah, 12 face cards out of 52 total. These don't overlap at R. These don't overlap at all. So again, we can add those pretty easily. Remember, when you're adding fractions, you just add the numerator. You keep the denominator the same. 16 out of 52. That does actually reduce. Both of those are divisible by 4. 4 over 13. Yep. Not bad. Okay. All right. Drawing a red card or a black 10. Hold on. So probability of red plus, because it's or, and then probability of getting a black 10. Okay, starting with probability of selecting a red card. Yeah, 26 out of 52 total red cards. Okay, plus, how many black 10s are there? Well, not 2 of the suits are red. These are red. So there's a black 10 in the clubs, because there'd be a 10 of clubs, and there'd be a 10 of spades. So how many total? 2 black 10s. Grand total would make 28 out of 52, which would simplify to, both of those are divisible by 4. 7 over 13. Very good. All right. Y'all want to try the next 2 with your group? Okay. I'm going to leave my card breakdown up here, but let's see if we can talk with our next group how we'd work the next 2 out. We'll come back. I'm going to set a timer for 3 minutes. And we'll come back in 3 minutes and discuss. So we're talking with our table.
And then that's 12, 26 Oh, you got? No, because I think you guys got the
Make sure you include everyone in your group. Everybody talking.
1, 2, 3, 4.
All independent.
5, 20 over. That was 2, 4, 6, 8 times 12, 6 times 10, 12. Wait, no, Jack. Is that a number? Jack's the numbers? I didn't know Jack's are 11. Oh, yeah, 10. I didn't know that those were numbers. I thought those were places. Well, you didn't answer it up. No, I didn't see the places. Oh, wait. So we, okay. So 1, 2, 3, 4, 5, 6. 6 times 124.
Alright, looks like most people have got the first one done.
I did not know that. I thought they were just a pretty hard.
A couple of people still working on that last question. I bet we don't need that last minute. 3, 2, 1. Only 2 minutes. Okay. What's my probability of drawing a king? There's 4 kings out of 52 total. And then it says or, so that means plus. What's my probability of drawing an even number? There are 20. Yeah, there's 20 even cards out of 52. Adding those would give me 24 out of 52, which is 6 over 13, because both divide by 4. What'd you forget? Anyone need to adjust what they wrote? Okay.
Wait, do queens not count as even cards?
No, a queen is a face card.
Well,
No, they don't. A queen is not a 12. A queen is a queen.
what?
In like games.
What game have y'all been playing?
Yeah.
No, they are not even numbers. They have faces on them. All right, adjust. Okay, next one says drawing a face card or a 7.
Isn't just the first one, but instead of it.
There's 12 face cards out of 52. Plus, or how many 7s are there? There's 4 7s. Yep. 28. Grand total, that would be 16 out of 52, which both are divisible by 4, which creates 4 out of 13. I know, sometimes you do end up with the right answer because sometimes your numbers are the same as the other numbers. All right, let's look at a little word problem on the bottom here. Everybody looking at the bottom? 50 tickets are sold for a raffle. You buy 2 tickets and your friend buys 3 tickets. Okay, I feel like those are important information. 50 tickets, you buy 2, friend buys 3. 1 ticket is randomly chosen as the winning ticket. What is the probability that you or your friend wins? Okay, so probability you or your friend. Anytime I see or, I'm like, ugh, that's telling me I need to add. So I'll need probability of you or probability of friend. Alright, starting with probability that you win.
It's
2 out of 50. Very good. And then or means plus. Probability that friend wins? 3 out of 50. Okay. Grand total would be 5 out of 50, which both of those are divisible by 5. 1 out of 10.
That's a pretty good chance.
Yeah, I think so too. The key for raffles is the less amount of tickets that are sold. Like, that's the first thing I would ask. I'd be like, how many tickets are sold already? If they say 1,000, I'd be like, never mind.
We're going to buy 1,000.
That's true. Okay. Next up, the overlapping events. The ones that do have some sort of outcome in common. If there's an outcome in common, you're going to have to subtract that because you don't want to accidentally count it double. Okay, so 2 events are overlapping. If they have 1 or more outcome in common, that's like rolling a 6 and rolling a 2. Or sorry, rolling an even number and rolling a 6. Like, those have an outcome in common because 6 is a 6 and also even. So the probability that either of the events is the sum of their single probabilities. So you're still adding because it does still say or. But you have to subtract the overlap minus both.
How do you find the overlap?
You just think about it. It's not hard. So probability of A or B where they are overlapping would be probability of A plus probability of B minus probability of them both happening, the overlap.
I just feel like I remember, I feel like I remember
It being more difficult.
a thing,
A formula.
the formula for that.
Let's look at it. Alright, first one's talking about a 6-sided die. 6-sided die, so not cards. Okay. Find each probability. So it says probability of rolling an even number or rolling a number less than 4. Okay, so probability of even plus probability of less than 4 minus probability of something that's both even and less than 4. Even and less than 4. Alright, let's start with even. How many even numbers are on a die?
3.
There's 3. 2, 4, 6. Yes, so 3 out of 6.
3, and then there's 3 numbers that are
Plus, how many numbers are less than 4?
3 out of
1, 2, 3. Very good. Minus, how many numbers are both even and less than 4? 1. What number is that? 2. Even and less than 4 would be the number 2. So we have to subtract that one number because technically we already counted it in both of these. So we don't want to count it again. So minus the even and less than 4 would be just 1 out of 6. Yep. So grand total would be 6 minus 1, which is 5 out of 6. Doesn't reduce. Probability of rolling a number greater than 3 or rolling an even. Let's see. Probability of greater than 3 plus probability of even minus probability of even and greater than 3. Okay, how many numbers on a die are greater than 3? There's 3. 3, yeah, 4, 5, and 6. So 3 out of 6. Plus probability of even, we already know that. 3 out of 6. Now, minus how many numbers on a die are both even and greater than 3? This one's 2, yes, because 4 and 6 are even and they're greater than 3. So that creates 6 minus 2, which is 4, 6, which is 2/3 if you reduce it. Okay? What? Yeah. You're doing fine. Okay. Given a standard deck of playing cards, back to our cards. Let's find the probability. These should have some overlap, so we'll have to think about that. Probability of drawing a spade or drawing a 7. Probability of spade or 7. Spade. Or is telling me I need to add probability of 7 minus what would be the overlap?
Spades and 7.
Spades and 7. Yeah, basically that's called the 7 of spades. Okay, how many spades are there?
4.
There's not 4 spades. There's 13 spades. It's a whole suit. 13 out of 52. How many 7s are there?
4.
There's 4. 1 for each of these, right? And then how many 7 of spades are there?
1.
1 7 of spades.
It's very
Mm-hmm. So let me see. That would be 17 minus 1, which is 16 out of 52, which again, those should both be divisible by 4. 4 over 13. I know, a lot of these will be very similar, because a lot of the card amounts are the same. Alright, let's do 2 minutes on the clock to figure out this next one. We're going to talk with our groups about it. I'll put the card information up here. We're doing a second one with our groups.
Oh wait, I didn't want to.
With our group.
8.
Oh wait, I forgot.
There's
11 over 26.
Over 13, right?
Well, that's what you did it wrong. That's why I did it wrong. Okay, wait. 12 over 52, right? The first number that you add. 12 over 52. So it's 13 over 16. 13. Yeah. Red card. There's. Oh, okay, I got what I did wrong. My bad.
38 minus 6.
Oh, 26. That's 38. Sorry, you're right.
Wait, what?
Yeah. 38. Right? 12 plus 26 is 38. Minus 2 is 34. Wait.
Wait, why are you minusing 2?
35.
let the dogs run around the yard.
Wait, why are you minusing 2?
Okay, 12 over 52. 26 over 52.
Yeah.
That's 38.
Yes.
And then you subtract 3 over 52.
Why is it 0?
Oh, it's 6 over 52. Oh my god. Today's not my day, guys. Okay. Wait, I put 32. Oh no. Okay.
I can see a line.
32. It's 32, right? And then what's half of 32? 1.
Alright, let's see what we come up with.
Oh, good.
Probability of drawing a face card or a red card. Is there any overlap in that? Yeah, there are red face cards. So we would need probability of face plus probability of red minus probability of the red faces. The rosacea cards. Alright, how many face cards are there?
12.
There are 12, yes, because there's 3 on each of these suits. So 12 out of 52. Plus, how many red cards are there? 26. Half the deck is red. Good. Minus, how many of those face cards are also red cards? 6, right, because they should, the face cards, you'd have these sets right here. So you'd have 1, 2, 3, 4, 5, 6. 6 out of 52. What does that make grand total when we add them? 32 out of 52. 8 over 13. Very nice. Okay. Two-way tables. All two-way tables. Alright, use the two-way table to find the probability. First, let's look through it. So a two-way table means you can read it vertically. So in the columns you have freshman, sophomore, junior, senior, and then the total. On the horizontal columns you just have the breakdown of boys and girls. There's lots of different ways they can ask questions on these two-way tables, but this question says probability of getting a senior or a girl. Is there any overlap in that? Are there girls that are also seniors?
No.
Yes, there is overlap in that. Alright. So we need probability of senior plus probability of girl minus probability of girl seniors. Okay. Starting with seniors. There's how many total seniors? 202 out of how many total? 808. Okay. There's how many total girls? 412 out of 808. So you see how we had to read that sideways? Okay. And then how many girls are also seniors? 108. Yes, that is this one right here. So we'll subtract that because technically we counted them already, so we don't need to count them again. That's why we take away the overlap. If we add, and subtract, how many does that get? 506. 506 over 808. What does that simplify to? 253 out of 404. I think so. What is that as a decimal? Just so I know. The decimal sometimes helps me to see the actual probability. Alright, like 62% of getting a senior that's all senior or a girl. Alright, the second question is not a disjoint or overlapping question. It's just kind of me showing you there's different ways you can read this table. So this one, there's no or in it, so I know there's not going to be an adding. But it just says probability of getting a girl that is a sophomore. Okay, so thinking about what we're going to have to calculate. We're not adding anything because it's not an or. So just starting with how many sophomores are there total? 210. So this should be our total. So instead of using the 808 total, we'll use the 210 for the total because we need a girl that is a sophomore. So we don't care about total. We just care about a girl that is a sophomore.
Oh, I thought it meant girls, so like the chance of a girl sophomore out of the total.
No, not out of the total. Just a girl that is a sophomore. So probability of getting, so my,
Oh, so you're choosing a random sophomore.
yes. So this would be 106 because there's 106 girls. Out of how many total sophomores? 210. No, it's not overlapping because it's not more than one event.
No, I mean like.
Oh, okay. Oh, that's like 50%. 53 out of 105. So just a different way to look at these two-way tables. I feel like they're very unique. All right, we got a weird question. Out of the 200 students in the senior class, 113 are either varsity or on the honor roll. Notice it says these are the ones that are or.
So these are the questions that
Right. There are 74 seniors who are varsity athletes and 51 seniors who are on the honor roll. What is the probability that a randomly selected senior is both varsity and on the honor roll? So this is going to use kind of, let me show you. It's going to use, where did we write it down? The formula. It basically uses the formula. We're given the probability of the first or the second one. This is given to us in the question. We're given these two. We're trying to find the probability of them both happening. We're trying to find the and part. So if we think about it, we'll be writing a little equation because we have this, we have this, we have this, we don't know this. Okay, so we'll be having to solve a tiny little equation. Okay, so I'm going to write it out. Probability of varsity or honor roll would equal probability of varsity plus probability of honor roll minus probability of varsity and honor roll. Ah, I saw it disconnect. Q, Z, X. Oh.
That's like 12.
All right, look at that equation. So let's fill in what we know. Can we find the or? Yes. It says 113 are varsity or honor roll. So 113 out of 200 should go here. Okay. Do we know varsity numbers? Yes. There's how many? 74 out of 200. Okay. Do we know honor roll numbers? Yes. 51 over 200. The only thing we don't know is this. This is what we're trying to solve for, them being varsity and on the honor roll. So let's put some sort of variable there. Which I want to put? X. Okay. What should I do first to solve this equation? We would add these two together. What is 74 over 200 plus 51 over 200? 125 over 200 minus X. Okay, then what?
subtract the 125.
Subtract the 125.
That's 12, negative 12 equals negative X.
Negative 12 over 200 equals negative X, which means X equals 12 over 200. Which reduces to?
3 over 50.
3 over 50, yeah. What is that as a decimal? 6%. 6% are varsity and on the honor roll. Well, that's exactly what we did, Mason. We just wrote an equation to do it. Yep. You did the same work. All right. Last thing for today is talking about complementary events. Complementary events, if they are disjoint events and one event that means one or the other must occur. There's some other probabilities as 1. So you'll often see these written as not something happening. Probability of not A. So I know that their probabilities total have to add to the whole number 1. So the probability of not A happening would be 1 minus the probability of A happening. We're almost done, Mason. Hold on. So the weather forecast claims that there's a 40% chance of snow tomorrow. What is the probability that will not snow tomorrow? 1 minus 40% is 60%. Very good. So probability of not snow would be 1 minus probability of snow. So 1 minus 40% is 60%. Or you can say 0.6, or you can say it as a fraction, whatever you want. All right, ready for the challenge question? Last one's the challenge question. There's nothing wrong with just looking at it. Maybe it'll be a bonus somewhere, and you'll be like, oh, yay, we knew how to do the bonus. All right, school t-shirts come in 5 colors: white, black, orange, teal, and magenta. 4 students are given t-shirts as prizes for volunteer service. They are handed out without regard to color. So literally just grabbing. Right. What is the probability that 2 or more students have the same color? Okay, so the probability that 2 or more students have the same color. So the probability that at least 2 are the same. We can actually use a complement on this. We can say that that's the same as 1 minus the probability that none of them are the same. None are the same. Because these are basically opposites. If at least 2 are the same, that's the opposite of having none of them are the same. All right, here we go. 1 minus. Let's start with the first person that chooses. Okay. The first person has how many color choices? There's 5, and of those 5, he could be offered how many of them? 5 of them. He could be offered 5 out of those 5. Because there's 5 colors still in the bin out of 5 total shirts. Second person goes up. There's a color missing now.
4 out of 5.
4 out of 5. Okay. 4 out of 5.
Is this 5 over 5 factorial though?
No. The top would technically be 5 factorial. The bottom would just be 5. Third person goes up. 2 shirts are gone.
3 over 5.
3 over 5. I'm just going to go down. Keep going.
What do we do with these numbers?
What do we do with them? We multiply them. Alright, I'm going to type that in my calculator because I don't feel like doing all that. 1 minus. That wouldn't be 120 over 5. That would be 120 over 5 to the 5th power.
Oh,
Right? 20, 60, yes. 120 is on the top. On the bottom, what's 5 to the 5th power? 25, 25. That would be 625 times 5. I'm just going to type 5 to the 5th power instead of trying to calculate it in my brain. 601 out of 625. Oh, wait, hold on. I didn't put parentheses. Let me double check. What?
it's like
Oh, no, it still says 601 out of 625.
I got 16.
1, 2, 3, 4, 5. 5 times 4 is 20. 20 times 3 is 60. 60 times 2 is 1. Oh, wait, hold on. There's only 4 students. What did I do wrong? I don't need this last guy. No, but I don't even need him. I don't need that extra one. There was only 4 students. I thought there were 5 students for those 5 shirts. It's ever so, yeah. There's only 4 students. Alright, let's adjust it.
So wait, so it's 120 over 125, right?
120 over 625. 120 over 125. Oh, excuse me, 101 over 125. I don't know where my brain got 120. I'd say that's pretty good. That would be something you might expect as like a bonus. Alright, let's try and knock out our DOL in the amount of time we have left, which is not... Yes.